All right, we're back. We're going to be on page 6 of Notes 21, but I wanted to start here with kind of like the general concept. We're always just doing pi, the big radius squared, minus the little radius squared, and then all times the height, right? So we're doing pi, the integral from a to b of big radius squared minus little radius squared, and then the height. So I keep calling the height, I keep calling dx the height. Could be dy, and it turns out that in the next problems, that's what we're going to do. So what I think you should do is you should find like a textbook. There are a lot of textbooks online, a lot of sample problem sets, whatever. Find some, do some volume problems, become like crazy proficient. Let's take a look at what happens when we just flip it up. So if we just understand it conceptually as pi big R squared minus pi little r squared, big volume minus little volume, there's like way less to kind of like memorize as you go along. So let's see if we can do this. So we're going to find the volume of the solid form by rotating y equals x squared, y equals 0, x equals 1 about the y-axis. All right, so this is the stuff of nightmare for some people, but not for us. So let's draw it. So these are our axes. Here's 1, I guess. Y equals x squared. So the region that we're dealing with is this region. I wish this was more like Microsoft Paint, where like you could just fill. And I feel like someone's about to tell me that it is like that, and there is like a fill feature. Like, why would there not be? But I don't exactly know. I haven't, that I'm aware of, I've not yet run into something like that. We're gonna rotate. So it's important to find this intersection point actually, which is 1, 1. Not a big deal. This is x equals 1. This is y equals 1. We're gonna rotate around the y-axis. All right, so to do that, we need a big radius and a little radius. So we are going to still draw them. So I'm going around the y-axis. My big radius is going to be here. So this is the big radius. And then for this, I would say that the big radius is going to be, well, how do I find this distance? I just do whatever's on the right-hand side minus whatever's on the left-hand side. So in this case, it's going to be 1 minus 0, right? Everywhere along this edge, it's x equals 1. Everywhere here, it's x equals 0, so 1 minus 0. Now I need a little radius. It's going to be a tiny bit more complicated, but really only a tiny bit. This is my little radius. So I need to subtract whatever this x-coordinate is, or this x-coordinate, or this x-coordinate from 0. Well, 0 from that. I need to know this so I can do this thing minus 0, this thing minus 0, this thing minus 0. So I need to really have this curve in terms of x. I need x equals something. Well, if y equals x squared, then x equals the square root of y. So nothing super groundbreaking there, but it does tell me that the little radius that I'm dealing, wow, I don't know how to fix that. The little radius that I'm dealing with is going to be the square root of y minus 0. Okay, so now, since we're going around a vertical axis, we need to use y values as our bounds. So we're going to get pi. The y value starts at 0, and then the y value stops at 1. So we're going from 0 to 1, and it's going to be the big radius squared minus the little radius squared dy. That's it. That's going to give us our volume. And I am going to get that on a calculator in a couple of minutes. First, I'm going to try to duplicate, well, I'm going to duplicate the picture and then, keep going. So you can hand draw this. I'm literally going to duplicate it and then try to erase things that I don't need. So what don't I need? I don't need you. I don't need you or you. I do kind of need everything else. Okay, so now what we're going around is x equals 1. So we're going around this. It's kind of busy there. We need a big radius. So we start here and we go until we hit the curve. That's our big radius. And then our little radius, there actually is nothing, right? Because we never leave. There's no hole. You're only gonna have a little radius if there's a hole in your thing when you're done. There's no hole. So all we get in this case is a big radius. So our big radius, we just want to do right take away left, right? That's how we, in terms of dy, we're always doing right take away left. So right is x equals 1. Left is the square root of y. So my big radius is 1 minus the square root of y. My little radius, there is none. So like I'm gonna write r equals 0, but like there's just no need for that. Now what are we doing? We're gonna integrate. So it's pi, integral from 0 to 1. These are y values. So y equals 0. This is y equals 1. The big radius squared minus the little radius squared, so minus 0, and then dy. And I'll get that on a calculator, but like, you know, no, nothing. All right, I'm gonna keep setting them up. Duplicate. So what am I duplicating? I'm gonna go back and duplicate this one again because I think it's like just easier to, I don't really know. I'm also gonna like clean this one and duplicate it again. So give me 1 second. Get rid of you, get rid of you, get rid of you. Duplicate this so that I can, you know, not have to do it over and over. Duplicate you and put you kind of there because I think I'm gonna need that. Okay. Next, we're going around x equals 4. So that's like way out here. Let's just say that that's 4. Probably not drawn to scale. Going around it. So what do we need? We need a big R and we need a little r. And that's it. Once you get with the program, I think you'll get these right pretty much all the time. It's going to be big R and then little r over here. So big R is going to be right take away left. So the right-hand curve is 4. The left-hand curve is radical y. For little r, the right-hand curve is 4. The left-hand curve is 1. So that's 3, obviously. All right, and then we're still just going from 0 to 1 on the y-axis. So it's going to be pi integral from 0 to 1 of big R, 4 minus root y, squared minus little y, which is just little r, I should say, squared dy. All right, let's set up one more, and then I'll use a calculator to get all the values, but like the values don't really matter, I don't think. It's really the concept. So I need to put in -3. X equals -3. All right, nothing's drawn to scale, but it doesn't really matter. Those are just there to help us. So we need a big R. Once you get what you're doing, you can do a lot of these. We need a little r. And in fact, you should like, I usually like hope that there's going to be a free response question on the AP exam that's just like straight up, you know, do your volume thing. All right, so right take away left, right, left. So it's going to be 1 minus -3. It's actually just cylinder. Little r, right take away left. So this is the square root of y. This is -3. So the square root of y, square root of y minus -3, which is the square root of y plus 3. And we can set it up. So if you can, and you can, like these are a gift. And watch, I got a bunch wrong, but I don't think I did. Big R squared minus little r squared dy. All right. I'm gonna knock them out on the calculator, write in the answers by hand. But you know, if you're confident in your calculator skills, you can get out of here. I'm just gonna punch them in, see what we get. Pi times integral 1 minus the square root of y squared, comma dy from 0 to 1. Pi over 2 is the first one. So that was A, I think. B is gonna be, I don't think I can like salvage this. I mean, maybe I could have, but it didn't seem worth it. Squared dy 0 to 1, pi over 6, smaller. Like intuitively smaller? I don't know. I have like no intuition on these. Let's see. So this one I can just change that to that. then change minus 3 squared. Get 13 pi over 6, bigger, intuitively bigger? No idea. And then this one, I think I'm gonna delete everything. And then just 4 squared minus quantity, square root of y plus 3 squared, 5 pi over 2. All right, I hope I got these right. There we go. So I'm gonna go, I guess I'll go back to the notes so you can see this, but the real magic was in setting them up. Setting them up big R, little r. Do not fear switching it to be around a vertical line. Doesn't matter, horizontal line, vertical line. We find big R, we find little r, we just do it. Like no drama whatsoever. All right, so given that we did that right, we're on to the next page. So I'm gonna cut this video here and I will see you there.